Okay, so hi everyone. My name is Quentin ADAM, and for those who don't know, I'm working on a company called Clever Cloud, and this is my day-to-day job. In fact, we're an IT automation company. So basically, we keep application online. So people just git push, and we auto heal, we auto monitoring, auto backups, auto scalability of everything with most of the platform. And what is very interesting about what we learn at Clever Cloud is there is big company like bank, assurance, or part of government, and a very small company like independent startups and things like that using the Clever Cloud. So basically, we learn a lot supporting them because it can advise us about good design, bad design, how teamwork, and things like that. And this is all we decide to give back to the community and give forward to the people to understand what we learn using all this kind of thing. So um, at the beginning, there is a no SQL word. Like these last few years, we whole listening about the whole data world exploding around there with plenty of new database everybody use with graph or not, schemaless and things like that with consistency, eventually consistency. And the cool things are no, we have a lot of choice and it can be very exciting to manage a lot of data. I think we have something with acidity, non-acidity, or concurrent writing, and manage mass of data and thing. And now, if you think about the data storage, there is plenty of people thinking first, okay, I will have some fun. And this is how MongoDB start to raise. This is how many people making the stuff. And right now, what's happening is people want to have fun using like cool database. So basically, we can have a small example about what can be a problem in database. The first thing we have to do is to create a playlist management app with multiple backend, like, it's a playlist app. We're able to play with Deezer, YouTube, Spotify, SoundCloud, I don't know where, backend, and keep the playlist history of the people, okay? It's kind of an example. If we think about that, we will use user management, so basic user management, uh, the playlist as entity, and the track history. And if you're looking at that, the thing is the track data is not consistent. It's something we will move across track provenance, but across time too, because the API of one provider of music can be changing by the time. So basically, what we know about this, about the object track, is we'll need schemaless. Everybody is okay with the term schemaless. Basically, it seems that we don't know what is the pattern of the data we will store inside the database. So everybody will say we have to use NoSQL because NoSQL it comes to schemaless. And the other thing is we have arbitrary data depth. Okay, what is really mean in proper language is we don't know how many level of the data we will be across because in the track object there can be an artist object, we can have a discography object, we can have almost like for example an image project with the thumbnail of the thing, and we don't know how many levels of data depth we will be. So if you think about that, we will require to use REST API from the provider, and we will have external data as JSON. So from there, I think I will use NoSQL something like, for example, MongoDB to solve that. Then I have another constraint coming there. I need a unique user by email because we can have two users sharing the same email. It will be like something we don't want. So if I say that means I need constraints. Constraints, it's quite important. It's one of the things we keep your database healthy. Keep the database healthy means the constraint is on the database and say the database cannot make something bad. Or if your database cannot support it, you have to make it from your code. So basically, it seems when a user tries to subscribe with an email, you have to try this email to get a user, and if there is no result, then you can try, or you have to raise an exception. But it will be on your code, and if your code fails, you will subscribe to user with the same email. And there you have a problem, because you have to be sure of your code on this constraint, because you are the sanity check of the database, and the database cannot sanitize itself. And the other problem we can have is continue deeply inside the problem we have, and we say which tracks are be played from 8 p.m. to 9 p.m. on a weekdays. This is quite complicated exploratory data. Weekdays, it have to be learned by something, understand properly time zone and timing, and this is quite complicated to understand. You know, like timing in informatics, in all the computer science, is something complicated, but meaning all this kind of thing in just one request is quite complicated. But if I say in the area near Paris, it's becoming harder and harder because I have to make geolocation, and geolocation is hard. We have tried to make its own geolocation positioning system inside the database who don't have the geolocation system. You know, this kind of stuff when we take latitude and longitude and say if it's less than that and less than that, it will be okay, and we draw just a square around a position, and it's not good at all, but we do this because we have no choice. Yeah, everybody sees this kind of thing. So we have a problem, and then I have to say, but mail user. So I'm looking for the track who have been played at a certain time in a certain area by certain type of users who don't have to relate it what is the track played by this guy. So I need a relationship system in data store. And there is one of the problem of the people because when we use something like MongoDB, we assert, yeah, I have an unstructured data, so basically just push all on the DB. Yeah, but I say this thing is related to this thing. It's quite complicated to express in a database who don't have the specificity to do that. So basically, it's becoming harder. But if I say, and I want to order this by the age of the users, and I need UI pagination 20 users by 20 users, it's becoming really difficult. Why? Because for most of the database, the order system and the pagination system, you need to move all in the RAM. So you need to pull all the database on RAM. It's complicated. So most of the problem I submit to you, except for the unstructured data system, we know how to resolve it. Order by, limit, offset, relationship. Yeah, we know there is SQL and Postgres SQL incoming. So basically, try to solve this kind of problematic with only Postgres to be quicker about majority of our problem. We can first create the table for the tracks. The table for the tracks is quite interesting because we say there is a track ID and there is a user ID saying the track is for this user. Interesting. When I write this, I say there is UUID. And UUID is a primary key, not serial. I want to just going deeper just a little bit about that is we need to be sure about that. Stop using serial with your primary key. Why? Serial or auto increment for people coming from the MySQL world. There's many problems with serial or auto increment system. First, it shows a large amount of information outside. You cannot go for a venture capital saying, yeah, we have 2 million users on our product, and when the guy subscribes, he gets a high T42. You know you are bullshitting him, but your competitors know this too. And the other problem about that is when you're doing that, people start to using the serial system as a count for their object on another for their history. But the primary key is not a count or another. The primary key is a unique identifier of your object inside your data model. So if you want an order, just put a serial with an order. If you want to count things, there is function to do that. But more complicated is if you are using serial with all your database, all your table in the database, they will get the same ID. So basically, when I want to delete the track and I say, okay, delete from blah blah blah, where ID blah, oh shit, it wasn't the table trap, it's the table users, and you just want to delete the users. If you have unique ID for all items in your database, you cannot do this kind of thing because all items have their own ID, have their own identity, and if you just are in the wrong table, oh, no problem, you will not find the ID because it's not existing. So the other thing about that is we whole write code will say, okay, insert this in the database. So by the way, return me the ID because I don't know the ID of the data I just put inside it. When you're using UUID, you can generate the UUID on the code, client side of the database on your code. You can generate the UUID, put the data on the database, and you already know the UUID because you have generated it in the code. So basically, it's a good move to generate all the data you put on the database there. Database is not there for create some data. It's there for store some data. So basically, I think it's a better idea to do that. And it's an answer about one of the most computer science problem well known is put name on things. And put name on things is having only one name. There is a very good blog article written by my Paul Clemente, which it's basically the Clever Cloud CTO, and it's available on this URL. It's pretty well explaining, and I assure you, please don't use serial as primary key. Then it was it was a digression. So basically, speaking about creating the tracks table of the problem. You have the status of the tracks, cool, and it uses a type which is track status. When you are doing something in SQL at Postgres, please use enum. Enum is something cool. It allows you to create a new type, like for example, alive or dead. Yeah, but the day the world will awake with dead people walking on the street, like in Walking Dead, how do you do? If you are made a single column with a true false boolean things called alive, true, false, yeah, but the people on Walking Dead, what are you doing for them? Yeah, we can make another column with another boolean here. Maybe they are non-dead. Yeah, but the people were considered alive and not undead, and you start to have this kind of weird flag combination, or the people who say, no, no problem, we just make an int, and we know with the int what is the thing. Okay, flash thing. In the backend, when you use enum, Postgres write an int and give you the result of the hint, because basically it's kind of foreign key for an example of type. Yeah, it's very well done. But when you retrieve the data, it brightens the data you have. So please use enum, because the data you put in the DB is really strong. True false have to be for something who can only be Boolean. And for something we can describe a state or say something intelligent about the data, use enum. If you look at the other things, there is some text, okay. There is interval. Interval is pretty cool things. Interval is something we can say it has begin at this time and it has end at this time. So basically, when you modelize a database with begin date and end date as the two columns, you are making a mismatch. What is interesting is not there is a begin date as an end date, is you are modelize an interval of the data, of the time, and this is the data itself. Because we can use it for many things, like is the data being played at this current time or not? And if you have not the interval as an objective self, you have to make a lot of crappy things like getting the two columns, trying if the thing is before this and end of this, etc. And if you're using this kind of stuff, you have just to call one function. So there is interval, there is a playing at with time and z, and create at timestamp tz. Yeah, because this is important. When you store some time, always store time zone. You don't know when, and sometimes you will have to internationalize, and then if there is no time zone, you are in a very bad situation. Timing in the whole computer science is a problem, so basically give the most of information possible in your database using a time zone. So, cool. And when you create the track table, you can have the track data. We use for this JSON B. Yeah, in PostgreSQL, you can use JSON data inside the DB. And basically, you can make this kind of stuff. We're just using like some text and say it's a type JSON, and yes, JSON is able to work on Postgres. So basically, there is two types like JSON and JSON B. Long story short, use JSON B. Okay? JSON was more like the experiment, and JSON B is like, oh, it's work. So basically, use JSON B. When we create the track table, we are able to use like user reference. So our track is able to link to the table with foreign key object, like we will do with whole SQL system. And then we have the SQL power. Like, because real database like PostgreSQL has able to give you the power of managing JSON. So basically, when you request JSON, you say something like that. If payload is our JSON B object, you just say, okay, I want with the operator with the arrow, you say, howe, I want the key, and you get it. This is awesome, because you have many operators and functions inside PostgreSQL to manage it, like, for example, test existence. If I ask for the simple JSON B, if B exists with the answer point like this, oh, I don't know what it's called in English, so basically, with the integration point, we can know if it's true or false, if B exists or not. But better than that, we can use all the SQL function on top of the data coming from the JSON. So basically, if I have some date inside my payload in JSON, I can say, by the way, is a timestamp with a time zone and using it. And this is becoming really powerful because you can trunk the time zone and okay, I have just like the month of the request or something like that. If I store all your Twitter posts with this kind of stuff, just storing the full JSON, I can have how many tweets you made per month just with a date trunk on this kind of stuff, and it's still JSON in the database. And there is plenty of things. You can know what is the array length. You have the data manipulation system. You have filters. You have also JSON pass, like the Higgs pass XML system inside the thing. Or you can have something to make your JSON pretty. So it's very well, and it's integrated with all the Postgres system. For example, all the Postgres function for managing timing. Like there is all you need inside it. Or you can have like Kunt. Kunt can be very complicated things to build on a NoSQL system, like for example MongoDB. And Kunt, the simple Kunt system in a very replicated system can be something like drive you crazy. But geolocation request, when you're using Postgres SQL, you're using also the database with using by the OpenStreetMap project. So basically, there is also Postgres extension, and you can make everything you want on geolocation system. And more, you can have performances. Because yeah, you can use an index inside of a data payload. So basically, you say, I will request a lot of this particular field on JSON, and you make an index on top of that, and your request will be pretty fast. So basically, there is people making fastest requests with Postgres than in small MONGO cluster for in some case, because index can be very faster. So basically, it's really fully integrated inside the system. The other thing is, while you have all the thing, you can use the transaction. Transactional systems are pretty efficient for a small company to manage a lot of things, and it can be very complicated to make transaction on a distributed area. So if you have transaction, you have all the acidity system used by a real database like PostgreSQL, and you can use it. So what I want to say about that is, why do not bootstrapping your project with that? How many projects I have seen with people saying, okay, I will use Hadoop cluster, but I have only 200 megabytes of data. I operate and launch a Hadoop cluster for so small data set. It's just stupidity. You can be very fast using PostgreSQL, iterate on your product, and then when you will be grow, okay, you will switch to noSQL, but the project has proved this viability. It can be a startup or a big corporation project, and you have the money to make this with big noSQL, Hadoop, Kafka, and non why system. So, yeah, plain old SQL can be very powerful because you just have to choose the database and the version you're using of the database. Most of the things I have shown you just work for PostgreSQL 9.4 and after. And this is quite important because it say you have to kill the ORM in your system. The problem with ORM is it's able to give you the possibility to use all the database. And you have the capacity of using the smaller common denominator of all database feature. If you can and use directly SQL inside your code, you can unlock the power of a database and use real feature of the database against just like the few things you can have. The other thing about that is using JDBC drivers. I don't know if you have opened the code of JDBC drivers, but sometimes it's quite complicated. And in fact, the first time I have a problem with the JDBC drivers, I go and run the code and say, okay, I will fix myself. and after I drive crazy, and I never fix the JDBC driver. But there is a solution. Not burning your computer, but there is this workaround. In PostgreSQL, you can say, all the row I have requested, all the results of the request, just put it into JSON. And there is something cool called row to JSON, and with a row to JSON, you're able to get all the results like this. And if you have all the results like this, it's simple. You have just to manage it like regular JSON code inside your system. So basically, you don't have to edit Postgres, JDBC driver, and can be very complicated and things like that. You just need to say to the database, everything is JSON, and then you have JSON parsing, and you know how to do that. So basically, what you have to say is to free your mind about data store and driver access and things like that. Just bypass the ORM, put everything on JSON inside the database, and communicate with it with as simple way as possible. People say, okay, PostgreSQL can be bigger than MONGO. Yes and no, because of the acidity. Everybody know what is acidity? Very quickly. Acid is atomicity, consistency, isolation, and durability. What is say? It guarantees what is going to happen to your data, and it guarantees that whole request will be processed in a precise order. It's very cool because you know if you make a cell, then you can decrease the storage of the cell, and then if another customers want the same item that is not available, it will fail and say to the customer it's not possible and things like that. So it's very cool, it's very powerful, but it's designed a bottleneck. So basically, if you want consistency and atomicity of your request, you will have a bottleneck. Just simple thing. You have an eShop on a classic mode. So basically, the user is buying an hard drive, and the database transaction is about the stock, the order, the invoices, the customer account reward, all the kind of thing, and the transaction of the user is processed. Then the stock and the order are just perfectly synchronized. Everybody is okay. Life is going. And then the user will come and he buy an hard drive, and the transaction of the user A and the user B will happen right one after another. So it's okay. All the stock is perfectly synchronized. Now, we build an eShop on a multi-tenant mode. For example, Amazon Marketplace. Basically, if user A is buying an hard drive to the seller A, and the user B is buying a book on the seller B, you don't care about the transaction of the user A and the user B will be right after another, because it's not the same stock, it's not the same seller, it's not the same users, it's not the same data set at all, in fact. So basically, the obligation, the mandatory system, which means all the transaction will be right before another, is just a bottleneck. And is your data store needs is multi-tenancy, you are making a mistake using an acidity system, because you need more agility, but you have to manage all the transaction on your side using complex replication system and very lot of technology. And it's the same with concurrent insert. If I want to insert data in the database in the same time, it can be very complicated. And I'm not thinking about sharding and replica to be able to manage a huge quantity of data who cannot be on a single node. And the high availability, what can be some kind of reachable with master. So basically, choosing a data store is a real architecture job. It's not like PostgreSQL is better than MongoDB. You can have multiple time insertion system on MongoDB. You cannot have on PostgreSQL. We have sharding on MongoDB. You cannot have on PostgreSQL. The thing is choosing your data store wisely and know how to trick it for growing. Because which I just want to say to this is you're not locking it just only one node. Also, database systems like Postgres are able to use a master-slave replication. So basically, you just launch another PostgreSQL process in another thing and saying, okay, give me all the change and I will keep me updated. Then there is a first possibility to split the request on your code and say, okay, this is the slave, this is the master. When you want to write some data, put it on the master. When you want to read some data, just go on the slave. But you have also tooling in the PostgreSQL ecosystem, like pgpool. pgpool is a quite cool tool, able to do something impressive. It can read, in fact, you're talking to pgpool exactly the same way, like you're talking to the PostgreSQL database. From the client side, there is no difference, and pgpool will say, okay, I have 3 slaves and 1 master. This is a write request. I send it to the master. This is a read request. I send it to one of the slaves. This is pretty cool because it allows you to grow like quickly if you need to handle more requests. It's very interesting when you have a lot of read requests, like huge read requests with complicated requests, and very few writes. It can be quite interesting. You have to be managing some of, there is some trade-off on the configuration of pgpool. It's not that simple with how many a slave can be late and things like that. But basically, it allows you to do that. And there is another thing, is using replica for specific purpose. I'm explaining. I have a big database of the software as a service, okay, with all the users. And financial department has me to have some data insight about how many the users pay, when, from which country, things like that. So I write a huge SQL request like that, which takes a lot of time to do on the database. Problem doing that is you are attacking the first node. The first node, one who writes a request with a huge request, taking a timeout for all the others clients. My advice will be put a replica, a slave, with a huge amount of RAM outside the pool. You have all the data of the master inside it, like in real time. And when you're doing some BI request, just doing on this one. Because DB stability is driven by predictability. If you're using the database with every single request is every day the same thing, it's okay. And if there is one request taking like much more time than other, it's harder to monitor if everybody is okay. So basically, keep the level of the request on the same, and when you make some experiments, use a dedicated slave to make some experiments, so you won't break the production-ready system if there is a single problem. And then, there's much more tooling in the PostgreSQL community, like this one called POA, will drive you a lot of metrics about how is working your database and things like that, and advise you what is the index you can create to have more and more and more data and to have more performance about your request. So basically, this kind of tools is pretty cool. One of the most sad issue about Postgres is why it haven't been chosen by the PHP community as the main database concurrent from MySQL. In fact, Postgres is quite complicated to install and manage. And when people from PHP asking themselves about, okay, how we will manage to have a database, they say, okay, it seems there is few products. There is PostgreSQL, there is MySQL, there's and things like that. After a few weeks of test, no one of core contributor of PHP was able to set up a Postgres database inside in his computer. So he haven't been able to try it. So they choose MySQL because they cannot use Postgres. This is sad. You don't have to choose a technology because you cannot set up it on your laptop. This is why when you're trying a technology, please take the time to find an online as a service with free plan to just try it. Because, for example, Hadoop is cool. Set up Hadoop on your computer is not cool at all. So if you want to try Hadoop as a service, then ask yourself, okay, how I can build it in my project? Does it worth the time to set up it in a server or not, or something like that? And then you can try to figure out, is it a good idea or not? There is a free developer plan on Clever Cloud. So basically, it's just one-click launch. It costs nothing. You just say, okay, I want a database. You hit create, and you have a PostgreSQL database like right now. So basically, it's a cool thing. So if I can help you doing your test, I will be happy. Just remember, noSQL means not only SQL and not SQL at all. And that's why I think Postgres is one of the best tools we can have to manage data in a company. And you should pay attention to all this kind of thing. Thank you for listening. And if you have some questions, it's cool. And I have plenty of very cool Clever Cloud stickers on there. So thank you. Is there some question? No question at all?
Is there some reason to like use this JSON format or only for pretty printing? I mean, is there some benefit from speed perspective, or might I use some indexes that are not applicable for regular data using this JSON B format?
Yeah, in fact, you're using JSON B because you don't know what is in the JSON. You don't know the schema of the JSON, so you cannot put all the things in just regular column. So, if you have this and you need to make some select or some condition of select inside the JSON thing, you use indexer to improve the performance. But the first reason you use JSON is you don't know what is the data you are storing. You don't know what is the schema of the data. For example, the payload of a REST API response. Another question?
Thank you for great and funny presentation.
Thank you.
And actually, what about joins on join requests with these JSON fields inside? Do they fast enough?
Yeah, it's totally the same than other case where you have a joins in your database. So with the same constraints of a joins in your database, and you can require make a joins. You have all the fields you want from the table A and from the table B, and you just add what you want from the JSON B perspective, just a field or the whole payload or whatever you need, or even aware constraints. It's not a problem. So it's basically completely integrated with the system. And if you need to make something on the JSON B itself, it can be preferable to create an index to speed up the performances.
Is there any tool that would help in deadlock detection if there is a deadlocking system?
First, there is something very interesting inside Postgres database. I can show you. There is something quite interesting. It's the ability of. Sorry. I really want to just copy. Is it readable? Maybe I can be.
Good now.
For example, there I have. There is the request I show you before. Okay. The first thing we can say is explain me how is working the result, the select. And with this, it can explain you how many rows, what is the cost of a request, and all this kind of thing working. So basically, it can be quite interesting because you just say, okay, explain me how the requests work, and there, from the explained point, you can understand what is the problem, and you can say, okay, I need an index on this kind of thing. So basically, you're just taking your select request and putting explain on front of, and then it will explain you how the request is made and performed, and it will be able to manage you a solution for the system. Yeah. Am I clear on that? Or yeah, sure.
Kind of.
There is another question there.
You told that Postgres has like replication features.
Yeah.
And as far as I know, by default, it's like asynchronous replications with like shipment of like its internal logs to other replicas. Question is like how much read slaves might I have without harming performance of master server? Do you have this from your experience?
It depends of the right performances of your system. So basically, if you write a lot, you will share information to slave a lot. You can tweak if you can tweak what is a batch of sending new elements to slave, and I haven't tested that. So basically, it's just a main vision, but you can also deactivate all the index system on your primary master and activate write for indexes on pool of specific slave function of what you will need to perform of this pool of slaves as request. But I think when you are in this situation, you are making a lot of mistakes, and there is certainly a better solution. So basically, I don't know how many slaves that we can have, but I'm pretty sure you can have a lot. It depends of your hardware and how many you perform writing from the master.
Okay, and like there's thing called like replication lag. It's some delay between data sent from main server to like slave server. Like how big might it be? Because we had an idea like okay, we could like improve performance by setting up several slaves and like making write requests only to master, and all other transactions that are read only could be like thrown to like read slaves. It actually depends on flow. So if you need like to check after your transaction, you're not sure when this data will arrive.
In fact, you can you can make configuration specificity about what is the slave important to be up to date. So you can say the slave cannot be not up to date, and you have to wait for the confirmation of the slave is okay for proceeding the next request. You can do that, but it will be slowest. So basically, it's up to you. In fact, it's configuration voodoo, you know. Another question? Okay, so thank you very much, and please get some sticker.